So this video is basically a quick definition of what's considered Arrhenius acids. He was a Swedish chemist. And identifying acids, identifying bases, identifying salts, all of which will be called electrolytes. And what that means is they produce ions in water, which means if you put a salt, an acid or a base in water, it will conduct electricity because of the presence of ions. So let's talk about recognizing an acid first. So most acids have an easy thing to recognize, and there's a table K, and you might want to have this in front of you. If you want to do that and pause the video for a second, that's great. So a classic acid would be hydrochloric acid, or HCl. When HCl goes into water, it ionizes. And what that means is it breaks apart into H's and Cl's, but it doesn't break apart into H atoms and Cl atoms. It breaks it into hydrogen ions and chloride ions. When nitric acid goes into water, it breaks apart into hydrogen ions and nitrate ions. It's said to ionize. The key thing is the presence of this hydrogen ion in the water. Now, another way of drawing this is, let's say you had like hydrobromic acid, which would be HBr. You could show it reacting with water. And what it's doing is when it reacts with the water, see, because the hydrogen ion can't just hang out by itself. It's really defined by what acids do in water. That's the traditional definitions, okay? And when they react with the water, what happens, the Br minus ends up by itself, just like the chloride and the nitrate, and the H plus sticks to the water molecule. I mean, you can picture the water molecules, H, O, H. And remember, this side's negative over here, and it's got those pairs of electrons, right? And what happens is, the H plus from the acid basically sticks to the water molecule. So I'm going to read it like this. And it's H plus being added to it. So it's just turns this thing into this thing right here. This is called a hydronium. Now, here's the thing. This and this are both considered exactly the same thing. Because HCl doesn't just... These H pluses don't just hang out by themselves. They stick to water molecules. So you'll see this written either this way or this way. In both cases, these are both called hydroniums, which are just H plus or hydrogen ions. Okay, and they're going to use those terms hydrogen ions and hydroniums interchangeably. Now, there's another group of acids that looks a little bit different, okay? And I'm going to circle it in table K. These are called organic acids, and ethanoic acid is one example. See this COOH here, okay? Now, this is the weird thing. Organic acids will have lots of H's, but there's only one H that's ionizable. Most of the time, acids contain either nonmetals like chlorine, fluorine, and bromine, like the binary acids, or they have hydrogens attached to oxygens in the pi atomic ion. All right? This hydrogen right here is ionizable. And this thing is usually written as a Cu, and you have to just remember it and recognize it. If you see this structure in a molecule, it's going to be what they call an organic acid. Now, what will happen is this will break apart, and this is really acetic acid. It really has an acetate ion, which is C2H3, O2, and these are these other three H's here. Those don't come off the molecule, but one of them does come off the molecule. And it's going to stick to a water molecule just like all the other acids. Now, organic acids are weak acids, which means they don't ionize as much as strong acids. That's why you can put vinegar on your salad and it tastes sour, but it's not going to like burn you or something. All right? But they still ionize and they still produce these hydronium ions. So recognize the Cu and recognize H followed by some nonmetals. Now, bases are different. Bases do not produce hydroniums in water solution as their positive ion. Now, bases come in two versions, okay? One version is what I'm going to call a metal hydroxide. You can see the table right next to me over there, right? A metal hydroxide, and these are basically ionic compounds. They're not molecular, but one of the ions in them is the hydroxide ion, and that's what defines them as a base, because when these guys are dissolved in water as solids, right, when they dissolve in water, they break up into sodium ions and hydroxides, and the presence of this negative ion, the hydroxide, is what says that they are bases. Barium hydroxide will break up into barium ions and hydroxide ions. all of our strong bases are what they call metal hydroxides. So there's 3 of these bases listed there in the table. And then you got this weird guy down here, ammonia, right? Just like before, we had one of these acids that didn't start with an H and had something you had to really know, the Cu thing, right? For a base, nitrogenous bases are different. And you've heard about nitrogenous bases too, just like you've heard of organic acids, right? Because organic acids are things like, vitamin C and stuff like that, or vinegar. Nitrogenous bases are in DNA. All right, they're also amino acids contain a part of them that acts basic. All right, now let me try to show you how this works. Ammonia, when it goes into water, it reacts with the water. Now, this reaction does not go to completion, so it reaches an equilibrium. But when it goes into the water, what it does is it grabs some hydrogens off the water. So it goes from NH3 to being NH4+. Now, for those who remember, this is ammonia. This always confuses students, okay? And this is an ammonium polyatomic ion. But that's not what makes this a base. What makes this a base is when the hydrogen comes off the water. If you remove a hydrogen from the water, what you're left back with is a hydroxide. And so the one thing all bases have in common is when they go in the water, the amount of hydroxides increases. And that's really what it's about. Now, unfortunately for you, okay, there's 2 other things you need to be aware of. You need to be aware of salts, which are also electrolytes because they also produce ions, right? So bases produce ions, acids produce ions. Salts are other ionic compounds. Now, make sure you're clear. To be a good ionic compound that works as an electrolyte, you would have to be soluble. And that's why we have that solubility table, right? So something like AgCl, which is a salt, would not be a good electrolyte because it is going to be a solid. It's insoluble according to the reference tables, right? But anything else that involves ions, either starts with a metal, has a pi atomic ion, or has 2 pi atomic ions, like KNO3, potassium ion and a nitrate ion, or KCl, potassium ion and a chloride, potassium chloride. Any of these ionic compounds are salts. This is the basic idea. An ionic compound is either a salt or it's a base. All right, so, and the bases are very specific. So if you don't want to memorize stuff or use the tables, you're in trouble here, right? Bases are metals with hydroxides. Any other ionic compound is just a salt. If it is soluble, it can also be an electrolyte. Now, the reason I've got other there is because we need to see what we're going to see in multiple choice questions, which are things that are neither acids, nor bases, nor salts, some of which look really similar to things. So, let's get the easy stuff out of the way. Things like sugar. Sorry about that mark, I'm not going to bother. Okay, things like sugar, that's not an acid-base salt. That's not an electrolyte. Okay, anything that's like just carbons and hydrogens, like C5H12, that's... And these guys, when we start talking about pH, he's going to have a pH of 7. They're going to be neutral. They're not going to affect pH, all right? Now, the one that really throws students are alcohols. Now, alcohols have not a hydroxide. They have something called a hydroxyl. And this is such a nitpicky thing, but it's a chemistry thing. The hydroxyl is a group, not a pi atomic ion. Ethanol, which is what's in beer and wine and stuff, basically looks like this. And it has attached to it a hydroxyl like this. But this does not break off. It does not break off, so it doesn't it doesn't make hydroxides in the water. But really messes students up is you see something like this, CH3OH, and it starts to get confusing because you're like, wait a second, that's that thing I keep thinking about with bases. This is not a base. That's an alcohol. Alcohols have carbon and hydrogen and hydroxyl. They do not have a metal with a hydroxide, so you need to distinguish them. So what we're going to do now is we're going to practice. Okay, so what I did is I made a list here. And what I'm going to do is we're going to knock out some easy stuff first, okay? And so I made 24 things. And what I'm going to do is we're going to find all of the acids first. Now, acids either start with an H followed by nonmetals, or they have the COO, the Cu thing in them. So we're going to look for all our acids first. Ready? Okay, here come the acids. Right, I'm going to go down the first column. I'm looking at Cu, COOH, or H followed by nonmetals. So This is my acid. I'm going to circle all the acids. Here's an H with nonmetals, acid. H with nonmetals, acid. H with nonmetals, acid. H with nonmetal acids. Do I see any other H's followed by nonmetals? H is followed by nonmetals. Those are all of my acids. Done. All right. Now I'm going to find. There's 2 alcohols in there. Let's find those guys. Alcohols end with a hydroxyl, but they start with carbons, and they are going to be the ones that throw you. So I'm going to draw X's over my alcohols, and they are neutral and have no effect on pH. Ready? I want to look for carbon and a hydroxyl at the end. Here's one of them, right here, number 3, and here's this one right here. Okay, now that I've got the 2 alcohols out of the way, so these are my acids, these are my alcohols, which do not affect the pH and are not electrolytes, I'm going to find my bases. Bases are metals with hydroxides, or they contain NH3 or NH2 in them. They're nitrogenous bases. You'll never see the one NH2, but I figured I'd throw it in just to show it to you once at least. Okay? Base. Going down the list. Metal with hydroxide, base. Any other metals with metal with hydroxide, base. All right, I'm going to show there are 2 nitrogenous bases here. This is a base, this is nitrogenous base right here. And this is the nitrogenous base right here. All right, now I'm going to take care of all the things that are nothing. They're just organic molecules that contain carbon and hydrogen, and they're not acids and not bases and not even alcohols, okay? And what's going to be left are the salts. Sugar, an organic molecule. In this column, do I have any? Nope. Okay, now I'm going to find all the ionic compounds, all the salts. Salt. This is a tough one right here. That's a salt too. Salt. So, you probably want to do right now is to go back and redo this to make sure you can handle it. Then I'm going to do another page with all the answers again. Okay? Here's another list. I suggest I'm going to put all the answers up in order. I'm going to put the acids first. Then I'm going to do the bases. Then I'm going to do the salts. Then I'm going to mention the alcohols and the other things. I'm going to put them up there. You do it yourself. I suggest you pause it now. And then I'm going to put all the answers in. Remember, the acids start with H, are followed by nonmetals. The bases are metals with hydroxides or ammonia, NH3. It's in the table. The salts are going to be ionic, so they're going to have metals, okay, with nonmetals. They're ionic, or they're going to be like a metal with a polyatomic ion. Alcohols have the OH at the end. They look like bases, but they have this. And then you've got the organic acids, which you've got to be aware of. Good luck with the first assignment on this.